If you spent any time lately, worrying about the future of work, and I mean everyone from the logistics worker to the taxi driver or even a highly trained surgeon, you're seeing something happen. And it's a transformation that is, I think, far deeper than just simple automation. We are crossing a chasm where the science fiction promise of robotics is finally becoming a real integral part of our global economy. It's not about if a machine can do the job anymore. It's about when the machine becomes the system. And when a system like that changes, well, the entire investment landscape changes with it. So the question we're really tackling today is a crucial one for you, for anyone trying to stay ahead. What does this shift actually mean for the winners and the losers on the stock market? Welcome to the deep dive. Our mission today is to do a really focused financial and technological analysis of this incoming robotics wave. We're going to be drawing specifically from some expert perspectives shared by Muki Tenenbaum and Claudio Sucevicchi. We are trying to go beyond just the headlines to extract the deepest nuggets of insight about the public market plays as cognitive AI formally merges with, physical mechanics. We're moving from ancient philosophy, this old dream of the tireless worker, straight onto the balance sheets of humanoids, autonomous systems, and some really revolutionary medical tech.
And that dual focus is absolutely essential. The physical reality on one hand and the financial projection on the other. As the analysis from Muki Tenenbaum consistently stresses, the financial side of robotics comes from its ability to systematize and replace human decision-making at a huge scale. We really have to start with a rigorous analytical framework, and this is a crucial distinction. Simple automation it's everywhere. You have factory arms tightening a single screw, a conveyor belt on a fixed rate. That's legacy tech. True robotics in this new era, what we're talking about, is defined by decision-making mechanics. It has to operate, it has to choose actions, and navigate a dynamic 3D world autonomously.
Okay, let's unpack that because that's a huge shift. The core idea here is that robotics, after being kind of stuck in R&D for decades, is finally poised for this massive leap. And it's not happening separately from AI, is it? It's completely integrated. We are seeing the synthesis of the best machine intelligence with real-world physical action.
Exactly. And to understand why some companies are getting these astronomical valuations and why others are facing, frankly, an existential threat, you first have to get Tenenbaum's definition of a modern robot. A robot, in this context, it has to have a level of awareness, of flexibility.
Right. An analogy we hear a lot is the elevator. It takes an order, you press a button, and it moves up or down. But it's operating in this fixed, predefined world. It performs one task. There are no surprises.
Precisely. If that elevator has a fire or a power outage, it just stops. It doesn't find another way. It doesn't interact with, complex human behavior. For Tenenbaum, the robot has to travel, it has to move dynamically, and most crucially, it must make decisions in real time, based on unpredictable input. Think about that assembly line arm versus, say, Tesla's Optimus humanoid. Optimus is a huge, high-stakes bet on decision-making in a general environment, doing any task a human can. That factory arm is just a dumb, specialized tool.
I really appreciate that we're starting with the philosophy before the finance. Because Muki Tenenbaum makes this fascinating point that this is a really deep historical desire. This isn't just a new tech fad. This concept of the working machine goes back, what, millennia?
It's an ancient preoccupation. The analysis takes us all the way back to 500 BCE. It draws a direct line from Greek philosophy. Aristotle, in his writing about the divine realm, he talked about automata. He imagined that in the paradise of the gods, on Mount Olympus, there would be these working machines that could take orders, maybe fetch a drink, and just perform labor effortlessly. And this just shows the fundamental human desire for an entity that works on command, freeing us up for other things.
And that desire just fast forwards through history. It becomes these cultural legends like the golem in 18th century Prague.
The golem is such a powerful expression of that same idea, especially the desire for a tireless, protective entity. The legend, as you know, is about a rabbi creating a clayman, the golem, to defend the Jewish community. Muki Tenenbaum points out that the word golem in Hebrew actually means cocoon, something incomplete, not yet fully formed, which is so resonant with the early stages of robotics, isn't it? And of course, the word robot itself comes from the Czech word robota, which just means to work or forced labor. The history is literally baked into the name. So this ancient desire for a tireless worker now meets modern capital markets. And the first place capital goes is where the ROI is clearest, replacing the human operator.
That link is so important. But before we get to the successful stuff, Tenenbaum warns us that we're still dealing with some some intermediate, even deceptive versions of humanoids right now.
Absolutely. The discussion highlights the Tokyo Cafe example. You go there, you see these small, seemingly functional robots serving food and talking.
Yeah.
But the autonomy is a complete facade. There's a human operator, often a disabled person, which is meaningful employment, sitting miles, maybe thousands of miles away, controlling the robot through its cameras and its microphones. It's telepresence. It's not true robotics.
It's just very sophisticated remote control, a kind of digital puppetry.
Precisely. And Tenenbaum cautions that the first wave of domestic robots might just use this model. He calls them a TV with legs.
A TV with legs. I like that.
It's a mobile interface controlled by a human, maybe in a low-cost labor market like India, who's managing the machine just through visual feedback. So the implication for you, the consumer, is that you're still paying for human labor. It's just deployed remotely, which is a far cry from the efficient autonomous replacement we're all expecting.
So if that's the disappointing present, where is the real bet being placed on true autonomy? We all know Boston Dynamics demonstrated that incredible mechanical agility with their, running and jumping robot dogs.
Boston Dynamics, they pushed the mechanical envelope. They proved that sophisticated movement was possible. But the market's focus has decisively shifted. It's now on general-purpose humanoids, and the prime example is Tesla's Optimus. And this is where we hit the most critical financial insight from Mookie Tenenbaum about Tesla's valuation.
Okay, this needs a real deep dive. Why does Tesla consistently trade at a price-to-earnings ratio that can spike above 250, while, established automakers like Ford or GM are in the low single digits?
It's simple, but it's also profound. The market is not betting on the car manufacturing business. That's a mature, low-margin industry. The global car market, while huge, is ultimately capped.
Right. There's only so many cars you can sell.
Exactly. Yeah. The market is betting on the total addressable market, the TAM of the Optimus robot, and the automation technology that underpins it.
Can you just quantify that difference in scale for us?
Sure. Think about it this way. The global auto market is measured in trillions of dollars. The global human labor market, every repetitive physical job, from factory work to domestic help, is measured in the tens, if not hundreds, of trillions of dollars annually.
Wow.
So if Optimus can replace just, say, 10% of global physical human labor, the revenue opportunity for Tesla would just dwarf the entire automotive industry several times over. That is why investors are willing to pay $250 for every $1 of current earnings. They are buying the potential to monetize the global labor force, not the Model 3. That is the systematic bet Mookie Tenenbaum identifies as driving that valuation.
That really establishes the magnitude of the bet. It's the robot tech stack driving the stock, not the car volume. Which naturally leads us right into our next major sector, robotics in motion autonomous vehicles. When we define a robot as a system that has to travel and make dynamic decisions in a complex world, the core criteria we just laid out, the self-driving car is the most mature, high-stakes example we have right now.
It is the vanguard, and the stakes are incredibly high. The vehicle has to constantly assess traffic, plot routes minute by minute, identify obstacles, predict what other drivers are going to do,
Right.
and execute these split-second maneuvers. This is the epitome of decision-making robotics. The technological foundation for this was pioneered heavily by the Israeli company Mobileye, which really pushed things from basic driver assistance systems to full, complex, level 4 and 5 autonomy.
And the deployment isn't some distant promise anymore. Waymo, which is Google, is operating robotaxis already in places like San Francisco, and they're testing in New York. You see the aggressive push in China with Baidu's software, and of course Musk's plans for his own robotaxi fleet.
And it's moving beyond the ground. The analysis mentions robotized helicopters, autonomous planes. Dubai, for example, has been a key test bed for both autonomous ground vehicles and aerial transport. This is critical because it signals a comprehensive, systematic replacement of all transport labor.
Okay, so let's identify the first major group of financial losers in the transportation sector. Mookie Tenenbaum is pretty unambiguous here. He suggests the autonomous vehicle spells the death of Uber and Lyft, as we know them.
It's an existential threat to their financial model. Absolutely. Uber and Lyft, that's UBR and LAFT, they rely on efficiently managing a huge distributed network of human-owned capital, the driver in their car.
Right.
While they could theoretically pivot to owning the robot car fleet, the system they built is based on human labor scarcity. Once you eliminate that scarcity, the price floor just collapses.
The moment you take out the human driver's wage, their insurance, the need to stop for brakes, the whole cost structure just changes radically.
Absolutely.
Yeah.
The service immediately becomes a commodity. The autonomous car drives faster, more reliably, and it can offer customized things, personalized music, climate control, window tints, all without any human interaction. This high-friction, human-dependent model is completely shattered. So Uber and Lyft stocks face massive headwinds because the market understands their network effect advantage just diminishes when the platform is simply connecting a user to a commodity robot service. The cheapest, most efficient fleet operator wins, not necessarily the best app.
So the competition shifts. It's not about managing labor anymore. It's about managing hardware efficiency. But there is a real human element here, fear. Tenenbaum addresses this psychological barrier, stepping into an autonomous car, or even worse, a plane with no pilot. Will that resistance actually stop this from happening?
It's a very natural psychological barrier, no question. But Tenenbaum's assessment suggests that this resistance will ultimately be overcome by the most universal language in finance: price. If a plane with a human crew costs $1,000 and a fully automated plane, which will eventually be statistically safer, costs $500, a 50% discount, most of the public, or at least the price-sensitive majority, will choose the cheaper automated option.
But if they are safer, why hasn't regulation already forced the change? Even if the price difference were smaller, is the resistance really just about price?
That's a great question. Right now, regulation moves slowly. That's partly due to lobbying from existing industries and partly due to the liability questions in this transitional period. But the aviation industry is a powerful analogy. It's incredibly safe, precisely because automation is already so highly integrated. Mookie Tenenbaum argues that once full automation proves its safety parity on the ground, the cost savings become this irresistible lever for mass adoption. Consumers will vote with their wallets, and that will accelerate the systematic change faster than regulations can slow it down.
So the economic incentive is strong enough to override human reluctance. Okay, we're moving now from the road to the warehouse. The impact of robotics is far broader. It's hitting the entire global supply chain and the traditional blue-collar labor market.
Absolutely. The factory floor and logistics are the next major fronts. And that's primarily because the tasks there are often repetitive and require less complex, generalized intelligence than, say, domestic service. This first systematic wave of robotic labor will specifically target those repetitive, physical, manual tasks currently done by low-skilled or temporary employees. That's where the calculation for replacing a human wage with a machine's operational costs offers immediate high returns.
And Amazon, not surprisingly, is a key player here. They're tackling both the internal logistics and the external delivery problem at the same time.
Amazon is pursuing a dual strategy. Internally, within their massive fulfillment centers, they already use robots extensively for inventory management. They're focused on fully robotizing the highly complex 3D world of the warehouse. Externally, they're developing all forms of autonomous delivery: vans, small pavement robots, drone integration.
And as we mentioned earlier, operating in a 3D world, the physical environment, not the cognitive logosera of pure cloud AI, that's the hard part.
It is the key bottleneck. A robot in a warehouse has to deal with gravity, unexpected human movements, uneven floors, and the just sheer complexity of picking items of all different sizes and shapes. This requires a multi-year learning curve for the technology to fully adapt and replace humans seamlessly. Mookie Tenenbaum suggests we're still talking about maybe 2 to 3 years of high-volume adjustment and training, but the market is already pricing in the successful completion of that curve. It understands the massive financial efficiency gains waiting at the end.
So, following that thread of financial losers, if fulfillment and delivery are robotized, traditional carriers like FedEx and UPS must be, well, significantly damaged.
That's correct. The city-based robotization of last-mile deliveries severely undermines their operational model. They're still tied to the human wage structure and all the scheduling issues. Furthermore, companies like DoorDash, which rely entirely on human gig workers for, meal and grocery delivery, are seriously threatened. Their whole value proposition disappears the moment delivery becomes a simple, low-cost autonomous function. Tenenbaum points out that companies like Symbiotic, that's SYM, which focuses specifically on the complex automation software and hardware for logistics, they are positioning themselves as major beneficiaries. They're selling the tools that eliminate the need for the human driver or picker.
Could you just elaborate on what Symbiotic does? We're dropping these tickers, so I want to make sure the listener understands the underlying tech.
Sure. Symbiotic, trading as SYM, specializes in the logistics automation software and hardware designed to manage these dense, high-volume fulfillment centers. Just think about the complexity of an Amazon warehouse where you have all these different items that need to be sorted, stored, and picked. SYM provides the brain and the body for this system. It optimizes inventory placement and uses fleets of autonomous mobile robots to perform piece picking and conveyance. It drastically cuts human touch points and increases throughput. It is a pure-play bet on the automation of the supply chain backbone.
Now let's talk about the ripple effect. Beyond the logistics workers themselves, if physical workers are replaced by robots, which financial companies are hit hardest?
This is a crucial financial deduction. The biggest losers are the companies whose entire value proposition relies on recruiting, managing, and placing those physical workers.
The staffing agencies.
The staffing agencies. Their financial model is built on managing human scarcity, turnover, and labor relations. When robots eliminate scarcity and turnover, the middleman becomes obsolete.
Which specific companies does Tenenbaum identify here?
Mookie Tenenbaum specifically names global employment service giants like Recruit Holdings, that's RCRRF Manpower, and Puron. He notes that these stocks are already being canalized by the market because analysts see this coming. The full impact, however, is yet to hit. Once robots become common replacements for factory and logistics workers, the need for human temp staffing agencies, their core cash cow, just evaporates. This is not a cyclical downturn. It's a permanent structural derailing of their entire business model.
It's a pure obsolescence play. Let's pivot to the China factor. China is clearly in the robotics race with players like Xiaomi and Xpeng. Where does Mookie Tenenbaum place them in this global technological competition?
The assessment of China is cautious, but it's very informative. While China is aggressive driven by strategic goals like Made in China 2025, Tenenbaum suggests their traditional strength lies in mass production and commoditization.
Right.
They excel at taking an established model and making it 50% cheaper.
Right.
But the critical question remains, are they the leaders in the fundamental generalized intelligence or the advanced flexible mechanical design?
So they might become the world's factory for robots, but maybe not the world's primary designer or AI innovator.
Precisely. Tenenbaum suggests that the fundamental skeleton and the intelligence to move it, in a truly generalized way, might still be lagging Western and South Korean leaders. We see them deploy huge numbers of industrial automation systems, and they're excellent in drone technology. But the core humanoids require a leap in AI and mechanical engineering that is not yet fully proven at scale there. And this creates a massive geopolitical and financial dilemma for Beijing. Will the government accept being the low-margin manufacturing partner, the factory of the world for robots? Or will they continue to pour resources into the ambition of being the sole technological leader? If they choose mass production over intelligence leadership, it's going to severely hurt non-Chinese automation companies like Rocco Liefnick. They simply cannot compete with the aggressive government-subsidized pricing China can achieve on simpler, non-robotic automation systems. The world may soon be flooded with cheap, effective, but perhaps unintelligent robotic hardware.
That sets the stage for a global competition that's defined by who owns the intelligence, not just who owns the factory. We've covered transportation and logistics, but Mookie Tenenbaum suggests that the most interesting and revolutionary applications of robotics aren't outside the body, but deep inside it.
He views medical robotics as having arguably the largest potential impact on human quality of life and longevity, particularly for the expanding elderly population, those aged 60 or 65 and above. This is where ultra-precision and miniaturization become life-saving.
The frontier here is microrobotics and truly precision medicine. Can you detail this revolutionary concept?
The concept is profoundly simple. Instead of systemic drug delivery, which causes widespread damage, think of chemotherapy, which attacks both healthy and cancerous cells throughout the body.
Right, the scorched earth approach.
Exactly. Instead, tiny micro-robots can be deployed internally. These robots are often magnetically guided or built from bioresponsive materials. They can navigate the circulatory system and deliver medicine directly to, say, a tumor, eliminating the devastating side effects of current treatments.
To recap that, we're talking about moving from a scorched earth policy in drug delivery to targeted cellular level repair. What's the application space beyond cancer treatment?
The applications are immense.
Oh.
Beyond localized cancer treatment, this technology could repair cellular damage in real time, fix arterial blockages from the inside without invasive surgery, and offer non-invasive repair for structural joint damage, like knees and elbows. Miniaturization technology is constantly improving, allowing external operators or eventually onboard AI to control these internal devices with millimeter precision. Mookie Tenenbaum draws a comparison to the famous Israeli camera pill technology developed about 25 years ago, a device that navigates the digestive tract and takes thousands of photos. The mechanism of a self-contained navigable unit is similar, but the function moves from just diagnostics to full intervention, drug delivery, tumor ablation, or internal repair. This capability will fundamentally re-rate healthcare companies that successfully integrate it.
Speaking of existing successes, surgical robotics is already highly established, with the Da Vinci robot being the main example.
The Da Vinci system, developed by Intuitive Surgical ISRG, is the standard bearer. It performs complex operations, like gallbladder removal and prostate surgery, with incredible success. The key advantage, as confirmed by surgeons themselves, is the elimination of human physiological limits. Even the most experienced surgeon's hand naturally exhibits a microscopic tremor. The robot completely filters this out, which drastically improves surgical precision, reduces blood loss, and speeds up recovery times.
So, just as we saw losers in transportation and labor, the rise of surgical robotics must signal the end for companies that supply the tools for conventional human-held surgery.
It creates a major, undeniable structural challenge. The efficiency of robotic surgery means the entire suite of traditional surgical instruments, scalpels, clamps, retractors, everything ergonomically designed to be held by a human hand becomes obsolete. Robotics requires tools designed for precision, not ergonomics. Mookie Tenenbaum specifically names Becton Dickinson, or BDX, as a company whose historical business model, which is heavily reliant on high-margin consumable manual surgical tools, faces complete displacement. This is not a slight market dip. This is a permanent structural shrinkage, as robotic procedure volume inevitably climbs toward 100%.
So, the biggest winners in the medical space are those providing that robotic intelligence and hardware.
Exactly. Intuitive Surgical, ISRG, which owns the Da Vinci platform, and Medtronic, which is heavily invested in integrating microtechnology, are poised to capture this massive market shift. They're moving the industry from human-assisted, error-prone surgery to automated, error-free precision intervention.
We've looked across so many sectors, from self-driving fleets to internal microsurgery. Let's step back and look at the strategic economics of this whole wave. Specifically, the strategy of specialization versus integration, which Tenenbaum emphasizes, is vital for investors.
This is perhaps the most important point for long-term investors. Mookie Tenenbaum issues a strong warning against trying to manage the entire vertical chain integrating core hardware design with deep software development and fabrication. He calls it the Intel mistake. Okay, explain the Intel mistake in this context.
Intel, historically, tried to do everything. They designed the core silicon architecture, the x86, they fabricated it in-house, owning the fabs, and they managed the entire computing ecosystem. By integrating all these functions, they failed to be world-class specialists in any single one. And that led to years of manufacturing delays and architectural stagnation. They were just caught flat-footed by competitors who specialized.
So the lesson for investors in the robotics age is specialization wins. Correct. Look at the winning architecture today. NVIDIA focuses intently on its GPU architecture and the standardized software layer, CUDA, which controls the hardware. They outsource fabrication to companies like TSMC, which specializes in pure, high-volume hardware fabrication. Tenenbaum argues that integrating both software and hardware leads to non-specialization, slow innovation, and expensive mistakes. The capital markets reward extreme focus and expertise.
You mentioned CUDA, which is so critical for AI. For the uninitiated, why is CUDA so important in robotics and deep learning, and why does NVIDIA's ownership of this ecosystem give them such a financial moat?
CUDA is NVIDIA's proprietary parallel computing platform and programming model. In simple terms, it lets software developers harness the massive parallel processing power of the GPU, which is essential for the complex matrix math that deep learning requires. For a robot operating in the 3D world, this means low latency, real-time decision-making. Since CUDA has been the industry standard for so long, anyone developing advanced AI or robotic systems is pretty much locked into the NVIDIA ecosystem.
Yeah.
That creates an incredibly powerful, sticky revenue stream that keeps competitors out.
And speaking of speed and complexity, we should also talk about the role of specialized memory. The analysis highlights SK Hynix and Samsung. Why are they critical infrastructure players in robotics?
That brings us to high bandwidth memory, or HBM. This is the extremely fast, vertically stacked memory that's placed right next to the processor. Robots, unlike simple cloud servers, need to process massive amounts of sensor data, LiDAR, visual, auditory, and make a decision in milliseconds.
Right.
If the memory is too slow, the robot hesitates. And that could be catastrophic for an autonomous vehicle or a surgical microrobot. SK Hynix and Samsung are the key global providers of this high-density, low-latency HBM, making them essential cogs in the systematic expansion of robotics globally.
This specialization argument leads to a truly provocative look at the future of highly skilled human labor. Tenenbaum makes a profound prediction about developers, not just factory workers.
And here's where it gets really interesting. What is the ultimate role of the human designer, the software architect, when AI evolves further?
Tenenbaum predicts that ultimately AI will design the software and AI will design the hardware. This means the current human developers and engineers, the ones who manually create the interfaces and patch the disparate systems together, what he calls the seams of the system, will find their phase is temporary. This entire human-mediated phase of integration is expected to disappear surprisingly fast, maybe within 2 or 3 years as AI makes everything uniform, optimized, and commoditized.
That is a timeline that should make any human software architect or industrial designer nervous. It reinforces the dizzying speed of this systematic change. Now, let's look globally beyond the US and China, because we need to acknowledge South Korea as a serious player.
South Korea has demonstrated a clear understanding of the future. Hyundai, the auto giant, recognized that the value was shifting from internal combustion engines to robotics, and they proactively invested heavily by acquiring Boston Dynamics. This immediately gave them access to cutting-edge mechanical agility and control systems. Coupled with the memory dominance of Samsung and SK Hynix, this establishes South Korea as a major technological power, specializing in that crucial hardware backbone.
And this leads to a critical geopolitical note from Tenenbaum. South Korea is an active participant in what he calls the Silicon Pact, an informal alignment of advanced nations focused on advanced AI and robotics development. That includes Israel, Australia, the UK, and the United States. This pact underscores where the deep innovation and systematic leadership are currently concentrated, while China grapples with moving past its identity as the mass manufacturer.
It shows that the winners in this systematic revolution will likely be clusters of specialized nations and companies, not single integrated giants. We've covered extensive ground today. Before we wrap up, let's go through a final, comprehensive summary of the financial perspectives laid out by Muki Tenenbaum and Suchaviki across all the sectors we've discussed. We need that clear snapshot for the listener.
Certainly, on the side of the systematic winners, the companies making the right strategic moves into decision-making robotics, we have Tesla, primarily for the potential of Optimus and its generalized automation tech, not just cars. Hyundai, for its aggressive forward-looking acquisition of Boston Dynamics. Google, leveraging its AI expertise through Waymo. Amazon, for its dual-focus strategy on internal logistics and external autonomous delivery. Intuitive Surgical, or ISRG, dominating surgical robotics. And Medtronic, leading in microtechnology integration.
And what about the list of companies facing systemic headwinds or, outright obsolescence?
That list is focused on any company reliant on high-cost, high-friction human labor for physical tasks. In transportation, that includes ride-sharing networks like Uber and Lyft Uber, L-Line-RFT, and traditional package carriers that will struggle with city-based automation, like FedEx and UPS. The most critically hit sector, as Tenenbaum stresses, is employment services, Recruit Holdings, RCRF, Manpower, and Piran. They face a complete derailing of their business model. And finally, in the medical tools sector, Becton Dickinson BDX faces a major structural challenge as manual surgical instruments are systematically replaced by robotic platforms.
This has been a true deep dive, moving from the philosophical quest for the working machine, the automata or the golem, to the very real and immediate financial impact on the recruiting industry and precision medicine. This is truly the next systematic wave, and it's touching every corner of the economy with just surprising speed.
The overarching key insight we have to internalize from this analysis is that robotics in this era is about systematic action and decision-making in the complex three-dimensional world. And critically, the biggest financial shifts, the revaluation of companies and the penalization of others, are happening now. It's based on future expectations before the technology is even fully mature. The market is betting on the system being realized, not just the prototype.
And that profound shift leads us to our final provocative thought for you, the listener, to carry forward. We've extensively discussed how automation will take away manual physical jobs delivery, driving, factory work, and how companies reliant on those workers are struggling. But Muki Tenenbaum suggests that AI will eventually be sophisticated enough to design the intelligence and the hardware itself. So what happens to the highly skilled specialists, the industrial designers, the mechanical engineers, the software architects, and even the human surgeons, when the intelligence that manages the hardware and the software is also designed and optimized by AI? What is the final, essential role left for true human expertise in a system that learns to design itself?
A question that redefines the meaning of value in the 21st century economy.
Thank you for joining us for the deep dive.
Until next time.